Today, I am going to talk on uh, basic data structures. You can say stack, and this is the one of you can say simplest data structures. You can say sometimes in our real life applications we are using this concept. So stacks is just concept. This stack that means whenever let's say example you are have a collections of elements and now you are collecting them. So whenever you have a collections of object and you are just started collecting, so this is the one approach. Maybe we have a let's set of books. You have a one books, another books, another books. So last couple of classes session we understand the one data structures like list. We are collecting elements one by one in the sequence of element, and we also understand like a linked list is another way to collect data. That's data are linked to the another data that is another linked list. So similarly stack is also one way to collect the elements or the object. So what this approach say, we have a one elements, let's put here. Another element, put on the top of that, on the top of that. Put another element on the top of that. Put another element on the top of that. Put another element at the top of that. That is known as a stack. Means the first element here, second element here, third element here, fourth element here, fifth element here. In this way, you are storing, collecting. Someone asks, "Hey, give me the data." Then the whatever the last data, this is the first data. So first thing, what the elements you are putting out, this is the last one giving. This is known as a top of your stack. Okay, so we have a concept of the top of stacks. Whenever someone want to retrieve the element from the stacks, they are getting from the top. Top means the whatever the element, latest elements you are stored, that's your retrieve. That is the approach known as a stack. Like stack of a stack of book, a stack of uh, this is a stack of books, stacks of plates, lots of things. Whenever you go somewhere, lots of plated in party somewhere, they are putting one up at the top, one at the top, one at the top of that. That is known as a stacks of the plates. So stack is just a one way where we are arranging the data in a such fashion the last elements will get the first. That is known as a stack. So let's talk through it. Stack is the fundamental data structures in the Python or in the computer science. Whenever you start understand reading the data structure in your computer science, the same we study this concept. Okay, so that's allow last in the first out. So this is the principle. Whatever the data last in, they are going to the first out. So this is the kind of data structures known as stack. Stack means LIFO, last in, first out. Means ki what this is a look like a collections and the we are putting look like a vertically. That means this is the element one, then on the top of that another element, on the top of that another element, on the top of that element, another element. So this is the way we are storing element in the structure, and they have a one pointer that is the top pointer. From the top they are pointing the which is the latest the last data you are storing this structures. Okay, so the basic concept in the stack is the last in LIFO principle. Here example, imagine a structure plates as you see. Whenever you are arranging plates, the first plates you put here, next plates you put on the top of that, next plate put on the top of that, next plate put on the top of that, next plate put on the top of that. This is the you can making stacks of the plates. Someone ask, hey, give me the If you go to take the plates, you took the top plate. Next person, top plate. You add plate to the top and remove from the top. If you want to add more plates, you are again putting the top. More plates, putting the tops. You want to remove, you are removing from top. That means here the new elements are inserted at the top and elements removed from the top. The top is the one pointer, from there you can add the element, a top pointer from where you remove the element. This is the approach known as a stack. So last plate put you in, first you will take off. Simple and gone. So let's look how to which operation generally on stack we perform. These are the very basic common operations or method. Whenever you are going to implement stack data structures, you have to provide. At least first we have a push method. Push whatever the element you want to store in the stack. Pop is the data you want to retrieve. So remove and return the top of the element. Here push, what push do? Push to add the element at the top of his stacks. Another methods you can maybe peek or top. View the top without removing. Whenever you say pop, here we are going to remove the top element. Here peek and top, we just retrieve the data, but we're not removing them. Sometime you want to check the stack is empty, or sometime you check hey stack what the total number of element in this stack. So generally these operation push pop, these are two major operation. You are pushing or popping. These are the some additional operations also you can implement uh, in a stack. Okay, so let's implement. So the implementation of a stack is in the list. So you know we are already understand the two basic data structure. One is the list, one is the linked list. Linked list, linked list. So this data structure is you can implement in the both way. You can implement maybe using the simple list concept like this way, or you can implement it in the linked list. So let's look the both approach how we can implement it. The implementation of stack is very simple. Just first we make one stack, means one just we create one list, just we create one list. Okay, and whenever someone puts, that means we are going appending the last, appending at the last, appending at the last, means he always put the data on the top. Someone want to put take the data, always get the top. So stack very simplest way we can implement in the Python using the list. So let us look. So here we have just a stack, just create this. So we have created this stack data structure, and maybe you define the push element. So simply say hey, we are going to the push element. So this list is already provided the function append. Appends always push the data at the top or the end, you can say. Pop. Pop is what they're doing. Pop just going to check stack is have a sub elements or not. If maybe stack is empty. If someone no element, you can say stack is empty. Else just use the pop method inside the list already provided. Just pop and the particular methods are there. Okay, you want to pick me, just we have to check. We have to check the stack is empty, then return, and then pip, just you don't say pop remove the element. Yes, just give me the minus. Notice the whenever we study list data structure, here mention list is the work on the concept of your indexes. The indexes start from the 0 1 2 3 4 5. Similarly, another also indexes, positive, and one is a negative index that start from the -1, -2, -3, -4, -5. So this is the, whenever say -5, minus 1, that's indicate your last top element. So whenever you can just check view peak or pop, you can say top, that we just retrieve the minus 1, that's return the last element. Okay, maybe you want to check the stack is empty, just simply say, hey, whatever the length of is stack. So already we have no length is a function that we can use to check the number of element. If it is 0, then you can say stack is empty. Maybe you want to put the size. So how to set size? Hey, if length, get the size and return the size. So these are the basic operations in a stack. You can very easily implement using the list. By default, in the Python, you can say list data structures already implemented look like as a stack. Just append, always going to the and pop. They have already pop method, get the last element and remove them, as well as and pick and size and change. These are general operations. So let's test this. Let's display. Let you want to maybe one more function like clear. So let's stack. You can just say already created a stack. So whole thing you can write inside the class, and you can also access all the method. But here we can directly say, hey, push element something. Let's say I want to push 23, push 25. Let's check the display. Okay. So here your first stack 23, another 45, another 26. Okay. Let's check the pop and again display, and notice the pop means the last element, the 67s are popped, and remaining list is this. Maybe just you want to like uh, peak peak, and this will just after that again display. So notice here, just this is our original list. Just they return the top last is a peak is the 45, but they're not removing the element. Pop, whenever say pop is the remove the element from here. Notice the particular 67 data is removed here. So there is a major differences. Both are returning the top element, but this pop is remove element, peak is not remove element. If you want to check the size, a print, I can say size of stacks, you can get the size, current stack the 2. Okay. If you want to just clear the stacks, just clear and display. And you can stack is empty. So implementation approach of the stack is very simple. Just we can create one data structures as a stack in the form of list, and in the case of push, just we call the append method. They are putting the at the end. Okay, in the pop, first we check stack have a something. If not, then just use the pop method. Pick, just check stack is not empty, then just stack minus 1, they return the top elements. Okay, check the length, you can just apply stack length. So implementation of stack in a Python is a very simple. Just use the list data structure. So in short, list is the implemented as a form look like a stack. So let's so this is your one implementation of stack using the list. Let's sometime again say this whole code you can return in a custom class. Whatever you return, maybe here notice I have written everything inside manually. So even all these operation we can using the, so that is simple. We written one class, okay, class stack, okay, stack. Just is empty. Simply push. Just push them. Pop. Just software pop. Tick. Tick. Size. Size. And clear. Clear. Display. Print. So all these operations generally we are writing in a class. So if when we are defining one class, and class have a one variable item that hold the item in the form of list. And here again is length is empty. Just check length zero or not. You want to push again the same function. Stack our item dot append pop. This is a pop method. Pick, just say length minus whatever the length minus one item you give the last one. Okay, simply say minus one itself of size, just size. Clear, just assign the blank. And you want to print everything, just print everything as item. And now instead of that, I can say uh, stack, stack, and you can up perform push, some push elements here, push. Let's print the stacks. So now you can say stack 1, 2, 3, printed. Maybe you want to pop and again stack printed. One element at the last one is going to remove. Okay. Even you want to push again print, they are going to be put in the last. So this is the way we can simply maybe clear and again print. Then you find, hey, all the data are the stack is input. So implementation of stack is a very simplified way using this list data structure. Maybe directly write inside the main class, or you can write one class inside a class they will define a function, so that someone can use the class and after that they can call the function post pop. You want to similarly take everything whatever the methods we are defined here, size, clear. Okay, so let's the simple same way here define push method just append, pop method just pop, pick method just item minus one, length is the length, size the size. So implementation of all these operations is very simplified way we can implement stack data structure in Python using a list. This is a one way, but you can also implement the stack using the linked list, because we know the we are a collections of element we can manage using the list data structures or the linked list as well. So this stack concept also you can implement using the linked list. Okay, so notice whenever you are linked list, we have to start a we can create one class node, and node hold your data and your next pointer. Because whenever you're going to implement linked list, all the nodes are created independently, but we have to each nodes know what is my next node. Each node know what is my next node. So due to that, we need to create one data structure node. Node hold your elements and the next pointer. And after that, you can simply create one class and initialize your one again a top variable. And after that, you can implement the list. All the functions we can implement like push. You can just pushing the value at the top. At the top, just create the node, and whatever the top node, initialize the nest. First, you create the node, and it's become a header. Header always here up top, and it's okay. It says the top is equal to new node. Again, new node create a node, and that node will become a top. So always every node you are inserting, that's become your top. Okay, that's become your top. So look like here. first node you created, and you say this is the our top node, right? Again, new elements come, and again new elements you are creating. Now what you say? Key new element dot next equal to top. So here next is equal to this, and what is the top? Now this become a top. Okay, now this is the not become a top. So again new element come here. What say? New element dot next top. Here say here this is the next, this is the next, and now this top become a this is the top. So whenever someone says start, this is the first element, then the new element again go to the here. This become a top, and this is the next element. So always in the linked list, first element become a top while implementing. So in the linked list, that means you are going to push data is always at the first. In this way you can create the link. Similarly, you want to implement pop, simply say check first stack is empty or not empty, just put the top data, this is the top data return, and now next become a top this. Okay, so now pop data is topped. So in this way you can implement similarly peak, you can implement similar display. So let's look, let's remove, and I can class, let's a node node, and here we can say whatever the elements we are going to element element. Okay. This is the simple node data structure, and now let's create the class stack. Okay, stack. Now here you can implement this things. Okay, so here same again, first you're going to one variable, just like in the study linked list have a two variable top and head. Here using the terminology, instead of head you can say top is the basic terminology using in the stack data structure. Okay, this is a top, we creating this top, just checking the length empty, push, same going to create one node and saying this is your top of node, and link the next is the top node. Okay, so this is the way. So look like here, so here you can create one stacks, we can create one object stacks have a one pointer top. Okay, one pointer top. So whenever someone will try to, hey, I want to push new element, so they can create one node with element, let's 7 element, and you can say node dot next is equal to what is the next pointer here, they are pointing to the top, now they are going to point to the top. Okay, top, and now say what is the top pointing to this. So now top is the first element, they are going to the pointing. Again, let's see someone call again the push. Let's see, I can call again this element. So another push, create the new elements. Let's create the new element 8. You can say what is the next? What is the next here? They are next pointing to the top. Top is this. Now they are going to point into the this node. Okay, and now say top pointing to the new node. Now this is the, not the top. Now this is the become a top. Okay, the first top become 8, then 8 become to the same. Again new element come, again one new element you added, let's the 9. You can say new element 9, new element next top. What is the new element, what is the next, what is the next here, next set top is pointing to the 8, the new element would be pointing to the this one. Now say top become a new node, now top is not this, now top become a this node. So whenever someone say, hey, traverse the top, the first node, next node, next. In this way, you are implementing this the data structures. Again, new node come. Just let new node come here. Again, 10. What is the next? Next node is a top. Next node is next pointing to the top. Top is this one. What is the down? Now top become. Now top become this is top become, not this. This is the way 10, 9, 8, 7 you are created. So implementation of the stack is the so simplest using the linked list as well as. Again, you want to If you want to just pop, simply say, hey, just get the top elements. And again, so let's say here you are you are created created link like this created, and our top is pointing to this node. Okay, this the top is pointing to this node. Someone say, hey, just give me the top element. This element you are returning, and you have to remove this. How removing? Simply say top dot nest equal to top nest. So this is the nest, this is the nest, this is the linked list. So what say, now top become not this, now top become this. So this is the next time, this is the top. Again remove, top become this. Next time this is top. This is the way you can implement top. True. Size, you can check the size. Is it clearer? You want to define display, display, display. So this is the way you are displaying. Whenever you are going to displaying, just start from the top. So multiple way you can just implement whatever the approach you want. So the implementation is very, this is the simplest way. Even you can test this. Example. Push, push, and display. So notice we have the push element 10, 20, 30. We are getting this there. Okay. Maybe you want to pop, we pop. This is your, let's pick this, pop, you know, this way. So the way you can, if you want to display again, display, you can check the one elements are removed. So there are simplest way you can just implement that very simplified way. Just we had to clear the concept of the list data structures and the linked list, and implementation of stacks become a very simplified way. So this stacks many places you can say use. Sometime you want to build some editor kind of a functionality where you want to undo redo functionality. We can easily implement the stacks designs or stack data structures. You want to implement some backtracking tracing algorithms where you can use these stacks. Even you want to some expression evaluation, some maybe post-script notation or some regex evaluation of the approach you want to implement. You can use, even you can use the stacks are used whenever you say some callback function callbacks. So all the stacks implementation happen if you are going to recursive functions call, the stack data structure implemented. Stacks are many places used, many frameworks data structures used. So sometime where you are going to collect you are collecting the data or elements, I want to store such a fashion that whatever the data are always stored on the top, always stored on the top, and whenever someone going to retrieve, always get the latest data. So such scenario, you are use this stack data structures. Okay, so that is the points for today about the stacks. So you can say stack is the data structures which allow store you can store uh, elements in the stacks on the basis of on the top, on the top, on the tops, on the tops, on the tops. Someone want to get always the latest value get. So you can say last in, first out. Whatever the data inserted last, the latest data, you can say if you want to get, always come first. This is the LIFO principles are is the basic of the stack data structure. This stacks you can implement using maybe list or array data structures, list or array data structures, or using the link list as well as link list. The both way you can implement the stack data structures in the Python. So hope this information is helpful. Let's do some exercise. Write the code about, just do yourself and write this stack data structure. This is a very simplest way to implement the data structure stack using the list or the linked list. Okay, that's for the day. Thank you.